Hello, welcome back. In this video session you will see how to find the natural frequency of the system by matrix iteration method. Matrix iteration method, it is a numerical method to find the natural frequency of the system. It is a iteration methods. Okay, the iterations are in the form of matrices. Okay, let us see this method considering one problem. Okay, we will consider this problem to find the natural frequency of the system for this system by using matrix iteration method. In this there are three masses. For this system we need to find the natural frequency of the systems. We already know how to find the influence coefficients for these 3 degree of freedom system. There are 9 influence coefficients: A11, A12, A13, A21, A22, A33. A21, A22, A23, A31, A32, A33. Total 9 influence coefficients. You refer my influence coefficients video to find the influence coefficient for mass spring system. Okay, here in this method the displacement of the mass 1, mass 2 and mass 3, that is x1, x2, x3. Displacement of the mass 1, that is x1, it is written as equation. It is in terms of influence coefficients and the forces. Okay, what is A11 multiplied by 4mx1 double dot? 4mx1 double dot, it is the force, mx double dot, where m is the 4m, and x1 double dot, it is the acceleration. So 4m x1 double dot, it is the acceleration force. It is a force. When it is multiplied by the influence coefficient, it gives us displacement of the mass 1 due to unit force applied at the mass 1. Similarly, this term, it gives A12 multiplied by 2m x2 double dot. This 2m x2 double dot, it is the force. This force, the displacement of the mass 1 when a force of 2m x2 double dot is applied. Okay, similarly, this is the displacement of the mass 1 when this much of force is applied. So the total displacement of the mass 1, it is x1. Similarly, x2 and x3 are the displacement of the mass 2 and mass 3. We know that x1, it is a sine function or cos function. It can be presented as sine function and cos function. So substituting the value of x1, x2, x3 as x1 sin omega t, x2 sin omega t and x3 sin omega t, and substituting the value of x1 double dot, x2 double dot and x3 double dot in each equations, it can be written as in this form. So x1, it is the amplitude of the mass 1, x2 is the amplitude of the mass 2, x3 is the amplitude of mass 3. It is A11 4m omega square x1. Okay, in all the equations there is mass and omega square, it is common. All the equations, now we have 3 equations, it can be represented in this form. Omega square, it is common in all the sum, so it is taken outside, and this A, it is influence coefficient matrix. A11, A12, A13, A21, A22, A23, A31, A32, A33. It is a 3 by 3 matrix. It is influence coefficient matrix, and it is mass matrix. 4m, 2m, m, 4m, 2m, m, 4m, 2m, m. It is also 3 by 3 matrix, where m is common in all the terms, so m can also be taken as outside. So you can see here. Okay, in mass matrix, 4m, 2m, m, 4m, 2m, m, 4m, 2m, m. So mass, it is in all the terms, so it is taken outside. The multiplication of these two matrix, influence coefficient matrix and mass matrix, it gives us dynamic matrix. It is also called as the dynamic matrix. Okay, so these 3 equations, it can written in the form of matrices. Okay, x1, x2, x3, x1, x2, x3, and here omega square and m, it is common in all the terms, so omega square and m, and influence coefficients A11, A12, A13, A21, A22, A23, A31, A32, A33, and it is also multiplied with masses. M is taken outside, so the remaining values are 4, 2, 1, 4, 2, 1, 4, 2, 1. Okay, you have to write the equations in this form. where x is x1, x2, x3. Omega square, it is common in all the terms, and in case of mass matrix, m is common in all the terms. So what is remaining? The multiplication of influence coefficient and this mass matrix, it is a 3 by 3 matrix, and this x is also x1, x2, x3, it is common in all the equations. In the matrix iteration method, writing all these equations in this term, it is very important. Okay, this is the first step in the matrix iteration method. Okay, now for the given system, it is a 3-degree freedom of system. Now you need to substitute all these influence coefficients: a11, a12, a13, a21, a22, a23, a31, a32, a33. What is a11? When the mass 1 is pulled, then the displacement of the mass 1, mass 2 and mass 3, it is same. So a11 is equal to a21, that is equal to a31, and by Maxwell's theorem, a21 is equal to a12 and a31 is equal to a13. So by this we will get 5 influence coefficients. So what is a11? a11 is equal to the reciprocal of the spring stiffness 3k, 1 by 3k. Okay, there is, when it is pulled, only this spring it elongated, so it is 1 by 3k. Similarly, when the mass 2 is pulled, when this mass is pulled, these two springs get elongated, so the equivalent spring stiffness is 1 by 3k plus 1 by k, so it is 3 by 4k. So a22 is also equal to a32, and by Maxwell's reciprocal theorem, a23 is also equal to a32. So by this you will get a 3 influence coefficient. So the remaining one is a33. When the unit force is applied at this third mass, all the 3 springs get elongated. So the equivalent spring stiffness, that is 1 by k, is equal to 1 by 3k plus 1 by k plus 1 by k. Okay, that is a33. So now we have calculated all the influence coefficients. Substitute all the influence coefficients here. So a11, a21, a31, by reciprocal theorems, a21 is equal to a12 and a31 is equal to a13. Similarly, you find when the unit force is applied at the mass 2 and mass 3 will deflect with the same amount. So a22 is equal to a32, a32 is equal to a23. So it is 4 by 3k. And when the unit force is applied at the third mass, it is 7 by 3k. In all the influence coefficients, 1 by 3k is common. So along with omega square by m, omega square into m, you take 1 by 3k, it is common. So x1, x2, x3, substituting all the influence coefficients here and taking the 1 by 3k, it is outside, omega square m by 3k, and so the matrix, it has only numbers now, 421, 484, 487, x1, x2, x3. Okay, so now x1, x2, x3 is equal to omega square m by 3k, 421, 484, 487, x1, x2, x3. Okay, now we have this matrix. Now this x1, x2, x3, let us assume the initial displacements of the initial amplitudes are 1, 1, 1. For the first trial, let us assume it as 1, 1, 1. Okay, when it is assumed as 1, 1, multiplied by the multiplication of these two matrices, it gives us 7, 16, 19. Okay, the first value, when it is normalized as 1, you just take this 7 outside. Taking the 7 outside, so this it is 1, 7 by 7 it is 1, 16 by 7 it is 2.286, 19 by 7 it is 2.714. The first value in this matrix, always you take the first element outside, only the absolute value. Even though it is minus 7, you take only 7 outside. So taking this magnitudes outside, it has 1, 2.286, 2.74. For the next trial, you take, these are the new displacements. Instead of 1, 1, 1, now you take 1, 2.286, 2.714. These are the new displacements. Now multiplication of these two matrices gives us 11.28, 13.14.286.